The modern world is built on movement. But to move a mountain of steel across a hostile ocean, you need the most powerful machine ever conceived by man.
A piston the size of a car, slammed down with the force of a bomb.
The massive crankshaft rotates. It weighs 300 tons. Heavy oil drips from the bearings in slow motion.
If this engine fails, global supply chains freeze.
There is no roadside assistance in the middle of the Pacific.
Perfection isn't a goal. It's a survival requirement.
This is how you build a monster.
We begin 4,000 miles away, the Australian Outback.
High-grade iron ore. The DNA of the engine. To get it, we have to tear the crust apart.
The rock here is stubborn, ancient,
It doesn't give up its treasure easily.
But raw ore is useless. It needs to bleed. The truck's massive suspension compresses under the load, 400 tons per load.
The journey to the factory begins with a brutal commute.
Friction is the enemy here.
From train to ship to the industrial heartland of Asia.
This is the fortress where geology becomes engineering.
Timeline? Tight. Margin for error? 0.
To build the engine block, we need liquid steel.
Checking the recipe. Too much carbon, it cracks. Too little, it bends.
science takes the wheel.
While the metal cooks, the mold is prepped. Huge wooden patterns are dusted. Meanwhile, the shape is defined. The sand hardening like concrete. The wooden pattern is lifted out, leaving a hollow shape. A negative But before we pour, we simulate.
Fluid dynamics. Predicting the flow.
At this scale, molten steel behaves like water. It wants to splash.
A microscopic void today becomes a catastrophic failure tomorrow.
The simulation shows the liquid moving smoothly through gates and risers. To prevent this, the engineers design a complex circulatory system.
It must cool evenly. If the outside cools too fast, the inside tears apart.
The math is solid.
Now, we do it for real.
"90 tons of liquid star stuff.
Pour. The ladle tilts. A blinding stream of liquid metal hits the mold cup, the point of no return.
Once it starts, it cannot stop.
It races through the veins of the mold.
But the work isn't over. It's the waiting game.
It takes 2 full weeks just to cool down.
Like a fossil being born.
It's a block of iron. Now we need to make it an engine.
This is the CNC portal miller. Enter the Titan Maker.
It's about to shave steel like it's butter. This isn't brute force. The tolerance here is measured in microns.
Thinner than a human hair.
If the hole is too small, the piston seizes. If it's too big, compression is lost.
But machines don't have a conscience.
Meet the master machinist. 30 years on the floor.
He spots a microscopic burr. He picks up a small file. He feels imperfections the computer missed.
An engine is only as strong as its weakest connection.
You don't use a wrench for this. You use hydraulics.
We stretch the steel. Under 2,000 bars of pressure, the steel elongates. The nut is hand-turned down to lock the stretch in place. Locked in.
If this bolt loosens,
Redundancy. Every bolt has a backup.
The bearing shell. It looks like a mirror. A worker pours oil onto it, a layer of oil thinner than a sheet of paper.
It is finished.
But it's just a statue until we wake it up.
Everything leads to this moment.
it's alive.
Pressure's normal.
100,000 horsepower. Perfectly balanced.
Validated. Now, it must leave the nest. "2,000 tons of precision engineering, moving at 1 mile per hour.
we will never see it again.
Buried deep in the dark, it will run for 25 years.
From red earth to liquid fire to cold steel, bringing the world to your doorstep.
The beating heart of the global economy.